In this episode, we are going to learn finding the slopes of linear relations. Let's take a look at first example. In this example, we must use the table of values to find the slope. Remember from last year, the slope is equal rise over run. This year, we're gonna call the slope m. Remember, the rise is the difference in y and the run is the difference on x. Let's now find the differences of y. We start from bottom up. 11 take away 9. 9 take away 7. 7 take away 5. 5 take away 3. And if you can realize that, all our answers is 2. We can do the same to find the differences of x, but if you realize that those numbers, they go up by 1. Now we plug in the numbers for our formula. We know the difference in y is 2 divided by the difference in x is 1. Therefore, the slope is 2 over 1. Therefore, m equals 2. Remember always that we can graph the table of values. Let's make now the horizontal line, which is calling the x-axis. Then we make the vertical line, which we call it the y-axis. Then we plot each of the 5 points. 1, 3 is located here, 2, 5 is located here, 3, 7 is located here, 4, 9 is located here, and 5, 11 is located here. Now we connect all these points with a straight line. Remember that we found the slope of this line, it was positive 2. Also on the graph, you can see the line is going up to the right, increasing up by positive 2. Let's take a look at another example. Let's find the slope of this line using this table of values. Remember, slope is equal to rise over run, or m equals differences of y divided by differences of x. Let's first find the differences of y. Remember, start from bottom up. First, we'll do negative 6 minus negative 2. Then, we'll do minus 2 take away 2. Then, we'll do 2 take away 6. Then, we'll do 6 take away 10. Notice all our answers of differences of y equals negative 4. Now let's find our differences on x. Remember, we start from bottom up. First, we'll do 8 take away 6. Then we'll do 6 take away 4. Then we'll do 4 take away 2. Then at the end we do 2 take away 0. Notice that all the differences on x, same number, is 2. Now let's plug these numbers into our formula. M equals negative 4 over 2. When we divide, m equals negative 2. Notice the slope of this line is negative 2. Let's plot these points and look at the graph how the line looks like. First, we draw the x-axis. Then we draw the vertical y-axis. Now let's plot the points. 0, 10 is here. 2, 6 is here. 4, 2 is here. 6 and negative 2 is here. 8 and negative 6 is here. Now let's connect all these dots with a straight line. Notice that this line going down to the right, which it is negative slope. Let's look at the next example, finding the slope using a graph. In order to find the slope of a line on the graph, you need 2 points. In this case, we have 3 and 4. Also, we have 5 and 10. Remember, the slope is always equals the rise over run. In this case, our rise is 6 and the run is 2. Therefore, m equals 6 over 2. And when we divide these two numbers, the slope equals positive 3. This makes sense because the line is going up to the right, so it is positive slope. Also, this question could ask you to find y-intercept. On this graph, y-intercepts where the line graph crosses y-axis. And in this case, y-intercept is -5. Let's look at another example to find the slope and the y-intercept of a formula. Question 1, we have y equals 2x plus 3. Remember, of any formula of a line is y equals mx plus b. We know that in the formula of the line that m is the slope and b is the interception point. In this case, the slope is the number before x, which it is equals to 2, and the interception point is 3. In example B, if you realize the slope is the number before x, it is -4, and the interception point is 2. For the last example, let's use the table of values to find y-intercept. Let's look at question A. We know y-intercepts always when x equals to 0. In this case, we have y-intercepts because x is 0. Y equals 10. Therefore, the y-intercept equals 10. Now, let's look at question B. Remember, y-intercepts when x is 0, and on this table, we don't have x value 0. But we can extend the table of values and work backwards. So the pattern on axis goes up by 1. So if we're going to go backwards, then it's going to be the number is 0. So you see on y values increases by 2. So if you're going to go backwards, then the number will be 1. Therefore, the y-intercept on this table of values is 1. Remember that y-intercepts always when x is 0. And on the graph, the y-intercepts where the line graph crosses y-axis.